Hi all, today we will try to write a device driver. So we will try to write the device driver and try to load it using insmod, and then make a node and access, create a device, and then try to write into it using echo, and then try to read into using cat. So that's what we will be doing. So we will be using a simple device driver, chat device driver, which is simple character utility loading locality. So what this means is you will be using a memory. So into the memory you will be writing, and into from the memory you will be reading only. So it's not a actually chat device, but chat device driver, but memory is what is being used. No hardware is used, only memory. So in the kernel space there will be a memory. So into it we will write, and from that we will read. So we'll come to that later. So before that we have to understand about some structures, kernel structures, which are important for this device driver. So they are the inode, file operations, and one more is there, which is cdev. Cdev is there, which is the character device driver's structure. So inode is the device identity. So like each device is identified by two numbers. One is the major number. Major number, if say for example 10, 0, this is one device. This can be considered as one device. So this is unique for this device. So let's say this device name is /dev/ some name we can give, like SCULL 0. So this particular device will have this major number and this minor number. So okay. So if you open in multiple process this same device if you open, then they will have the same this thing. Inode will be the same. So like if you have process 1 opens this file, then the inode is same for this process 1 also. If process 2 opens this same file, then for this also inode will be same. For both of them inode is same for both of them, but each one will have a file pointer. So each one will have a different file pointer. So like these four structures are already right. Inode is device identity. So for this device it is going to be remain same. But for each file that you are opening, for this process you are opening this file, so for that the file pointer will differ. So for this the file pointer will be different, for this the file pointer will be different. So that's one thing. And then file operations is like what are the operations that we can do on this device. So like open, read, write. So the number of operations, close, release, some operations are there which we can do on this device. So those are operations which are defined in this structure. And cdev is the character device driver structure. So these are the main structures. So 4 are there. So inode, file pointer structure, and then the file operation structure, and then the cdev structure. So these are the kernel structure which are important for the device driver. So now we will look at the device SCULL device driver, simple SCULL device driver. So that you will see now. So this is the code. So actually I told you that there will be a memory. Into the memory you will be writing, and from there you will be reading. So this is the so like instead of assigning a big memory, so like sometimes the user might write some little amount of data, sometimes he might write large amount of data. So instead of upfront deciding the number of bytes ahead of time, we can decide we can split it into smaller chunks. So what I mean to say is, so like we will define quantum 4. These are some integer values. Quantum 4 and qset 4 means, so each qset, this is a pointer of buffer array integers. So this will point to 4 bytes. Next one, so qset is 2, right? So there will be two qsets. So each will point to 4 bytes. So based on if the user is giving only 4 bytes to the device, then only this one will be created. If he is giving 8 bytes, this one will be created. If he is doing 15 bytes, then this one also will be created. So on the fly, based on how much data the user is giving, based on that the memories will be created. So instead of giving like 4000 megabytes at one shot, you will be like whatever is the amount of data that user is giving, based on that the memory will be created. So this is the efficient way. So if you give upfront all the bytes, then if he is giving small amount of data, then all the memory will be wasted. So that's the one reason why, based on how much data the user is giving, that was only we will be allocating. So if you see the code here, so this is these things are there, right? These qset 0, qset 1, these are all maintained as a linked list. So this is the first one, this is second one, like that it will be maintained. So like that, so this is the linked list, this is the qset, same data structure is using as a pointer for next. So this is our device, so this is character device diverse structure. These are the some things which are needed for our device. So this is the data, that is the data structure that we are using to create the memories as and when the user gives the input. So that is this thing. Quantum is this side showed you, right? So quantum is how many bytes for each of this qset value, that much we are creating. Qset is how many qsets you are using for each node. So that's the thing. So qset is that one, quantum is that one, and int size is how many nodes you want to create. So that's one also you can give. So now you have created as a variable here, global variable, and device number is, this will have the major number and minor number. So these two has been created as a global variables. So in this file, these are global variables which are defined before this thing. So this is if at all the user is, this function is to reach to the memory, like this we are creating number of linked list, right? So if you are if he is asking, like, I want the data at offset some number, then in order to fetch that offset, this is what we are doing here in this function. So go to that particular linked list, particular value, and then in that offset we have to calculate. So for that, so if at all offset is giving us 10, then node number, and this is the math they are using, node number you will calculate which quantum is there, which offset, all those things you will calculate. So like if he is saying offset is 7, then it will come into this one. So offset is 14, then it will come into this one. So how to do that math and all those things he is showing here. So you can refer even the device drivers book, classic device drivers books, you can find that. So this is the math that they are doing. First identify the linked list in which it is there, and then in that offset wherever you want to read. So this is SCULL trim. So this is when the user opens the file in only write mode, then all the previous memory that has been allocated has to be released, has to be freed. So that's what is freeing memory you are doing. So SCULL open. So like this is container of means. So container of means this. So actually inode will have only this value. This inode will only be passed at the time of open. So but our device is in this one. SCULL dev is in this structure only. Our device is there. So how will you get this structure pointer? So that's what in open we will have inode. The sys open will pass only inode and the file pointer to this open function. So but we want this pointer. So that pointer you can obtain from this container of. So this will do a math, like this is there, right? cdev is there, right? icdev is what? Here it is here. This is there. So this much offset we have to subtract. Then we will reach to this SCULL dev pointer. So then we'll have the pointer of our device. So that's how. That's instead of doing the math every time, device drivers people have given as a container of some function is there, which we can pass this inode's cdev structure, and then the SCULL dev will be returned. So if you see a SCULL dev is this one, dev is returned, and that one will store in the file pointer. So file pointer is there, right? File pointer, I told you, right? 4 structures will be there. One is inode, one is file pointer, and file operations one, and then the cdev is the other one. cdev is this one. This is our device, this thing, device structure is this one. To obtain the device structure, we have only cdev structure, right? From that, subtracting this offset. So what is the offset here in this case? So one long int means this is 8 bytes, 8 plus 4 plus 4, 12. This will be some, this structure, whatever may be this structure size. So that offset will be minus, and that this pointer will be obtained. So instead of doing all those stuff, they were using container of. So that's what we are doing. So once we get this thing, we will store that immediately into the file pointer. So what will happen is, if at all you see here, so if you see any code when you are accessing, when you are opening a device, the file pointer will be returned. The file pointer will only be used in future. So write and read whatever is there, file pointer only will be used. So what we are doing is, inside the file pointer, in its private data, we are storing this our device's structure pointer, so that so that our entire device data can be accessed by the read and write. So the read and write can access the entire all these structures like cull set data, what is the memory, quantum values, q set value, size value, all those things it can access. So that's why when you are opening, cdev will be there in the inode. Inode means that the major number and minor number will be there. From there we are getting the SCULL and then we are immediately storing it in the private data of the file pointer, so that read and write can use it. So read and write, you can see read and write whatever is the from which position is reading, the same thing the math they are doing here. And then the SCULL follow means you will go into the pointer of that particular linked list, and then you obtain the whatever is the count of data that you are trying to read, that one will be copied to the user. So directly we cannot access the kernel memory, so we have to copy to user function you have to use. So similarly write, we are doing the same math here. So where you want to write in the memory, so if at all that memory is not available, then we will be creating using calloc, and then you will be at that position you will be writing the whatever is the amount of copy from user whatever is data is giving, that one you will be copying into this one. So that's the idea. So these whatever you have created, right, these file SCULL open, SCULL write, all those things, that you will be file operations. This one structure, 4 structures I told you, right, this one is one of them. So in that we will be assigning them these things like owner, this module, SCULL open. So when a user calls this thing open, this particular SCULL open will be called. So user doesn't have to remember what is my device drivers open, that name you need not have to worry. So it will be mapped here only. So that's the idea. So SCULL init, when you are doing init, you have to calloc. So when you do this one, the device major number will be assigned by the device by the system itself. So you don't have to worry about the major number. So one more is there. Cdev region register, one more is there, one more function. In that case we can give the major number, but we have to check in the entire system whichever major number is available, that one only we have to give. So this one system will directly generate. So this is useful, this is very useful. So if at all you are using Cdev region whatever the other function that I told you, right, if you use that one, you have to give the major number. So in your first system your major number will be available. If you say the same code with some other guy, in his system that major number will be used by some other process, some other device driver, then it will be a problem. So this will generate from the system will be generate the major number. So you can share this code to anyone can use it. So that's the idea. So this is what is used everywhere. So you can share this C code to anyone, and he can run it on his device also. So that's the idea. So init we are doing, cdev init we are doing, and then owner, this module we have to give the owner, and then quantum, whatever is the quantum that you have set, we have set it as, I think each one is of size 4000, that much 1000 q sets you have set. This memory only. So as and when the data user is giving data, then the memory will be created. That is the idea. So q set, these are setting, and then we are adding cdev add means, so these initialization part has to happen before the cdev add. So once cdev add is added, and if you do all these initializations after that, so after that then it will be a problem. So like once you do cdev add, the device will be available to the made available by the kernel, so anybody can use it. So if you do the initialization after that, if then these initializations will not be available and the kernel can crash. So that's one, I think kernel panning can happen. So all the initialization should happen, then only the cdev add should come. So even if you are doing some semaphore concurrency and all, we are taking care, all the semaphore initializations and all should come before the cdev add only. So after that there should not be any initializations should be there. So that's one thing. Then exit time, we are trim means we are destroying all the memories that you have created, and also the deleting the character device driver structure and all those things, unregistering the device number will have the major number and minor number. So now we will try to run this. So here it is. So there is a make file here. So if you see here, there is a make file. So this makefile is having this thing. So this is one way of writing makefile. Makefiles are different ways of writing. This is one of the way. This is used for device drivers, this way of writing. So this is the thing. So we will try to make it. So make I will give. So make. So it has been made now. Okay, that's okay. Now we have to give sudo insmod this particular. We have to insert this module into the kernel. So at runtime we are doing this. So static. This is dynamic loading. So actually, so this is we are doing insmod. So this is done. Now next what you have to do is we can see this. So like this SCULL module has been added to the kernel that we can see here. The message is ring buffer where we can see the messages where the kernel modules are inserted at that time, whatever the messages are there that we can see here. So if you see SCULL loaded, it is coming here. So SCULL is loaded. So now next we have to see the major number. What is the major number system has created? Since we are used alloc this thing, right? So major number we don't know. What a system given, that we have to check. So we can do cat proc. Here all the devices will be there. So we can check here, our SCULL will be there, SCULL simple will be there. So if you see here, 240 is the major number that he has given. So next what you have to do is we have to create a node. So we have to give this major number as 240. So this is the device, actual device we are creating now. So this is the device. So now we go here and then we create this. So device is created now. Now we can give the permissions like read, write, all the group and then user, all the which users we are giving the permissions, all those things. Then we can write. So like echo, we are giving SCULL. This much memory only will be created. So this is very efficient. So hello SCULL I am giving. So what I will do is I will give here echo I am giving. I am writing into this device. So this particular device I am writing this particular hello SCULL. So now it has been written. Now if you want to read it, then cat we can use it. So we can use cat and then you can, now if you see here, then you see whatever you have written, that one has been coming. Now I will do one more thing. Hello. So I will do. Now I will do cat again. So if you see, because in this case echo, what is happening, it is opening in the write mode. So whatever the memory has been created, it has been deleted. So if you want to append to whatever is hello SCULL is there, if you want to append, then you have to open it in read and write mode, and then we have to write. So for that you have to create a, so like this function you have to create here, read write mode you have to create, and then when you write then it will write append to it. So in this case it is opening and then opening in read mode. That's why the previous one is gone. So when you read, this is what is coming. So that's about this. So that's all. You can remove the module now. Sudo rm mod and then okay. Okay, this one we have to remove. This is a simple device driver or a mod you can do. So the driver is removed. If you see here again, tripod devices, this here it will not be there. Okay, I can grep we can do grep SCULL. So see, nothing is there here. So and it has been removed. Okay. So that's all about